gives you a method to check your work. So you can find the errors. Okay, so number 2. A times B is 4 by 4 matrix, 12, 19, negative 42, 37. B times A.
2 by 2.
What did I say?
4 by 4.
Yeah, I don't know why I said that. But yes, 2 by 2 is what I meant. B times A is the 2 by 2 matrix, 40, 42, negative 21, 9. I apologize to anyone watching this video for the audio because the audio is trash. I know. It's because my thing was dying and I didn't know it. So my thing is charging and you get some audio, but it's crappy. Hola, Bree. One nice thing for anyone watching this video, which is debatable how nice, but one nice thing is that you will actually be able to hear them now. You'll be able to see them. You'll be able to hear them. So when someone asks, do pigs fly? And I say yes, you will know what the yes was about. That's the truth. Okay. I wonder how terrible. What do we do? Yes. Number 4 is the 2 by 4 matrix. A times B is the 2 by 4 matrix. 24, 4, negative 40, 36, 35, negative 50, 45. And B times A is undefined. 6. A times B is a 3 by 3 matrix, 0, 12, negative 10, negative 6, negative 3, 17, negative 4, 20, negative 7. And B times A is a 2 by 2 matrix, negative 29, negative 8, 3, 19. 8, A times B is undefined. And B times A is a 4 by 3 matrix, 4, negative 78, negative 4, negative 18, negative 54, negative 42, 8, 33, 20, 28, negative 33, 48.
What's the first number in that matrix? You didn't say it.
4. I think I did, but
okay.
We have a recording. We can find out whether I'm a liar or not. Number 10 is factory 1. I love word problems that are like that, where it's like all this crap and the answer's factory 1. Feels anticlimactic. I like Disney. I don't even know what I mean by that, but it seems
That's a job because fun. Someone in the class is wearing a Disney shirt.
Well, yes, that is why I said it. I just don't know what I meant by it. Oh, I see. You're telling the camera. I said yes.
For the historical record.
For the historical record. So the augmented matrices on 12 through 16 or 18 are easy. I'm not going to read the augmented matrix, but the answers, when you do the methods, answer number 12 is 3, negative 0.58. 14 is negative 8, 11, negative 13. 16 is negative 1, negative 24, negative 9. 18 is 9, 11, negative 25.
1, 12, negative 0.5, negative 1/2. You count that
Yeah.
It doesn't matter what.
Doesn't matter. 20 is yes. 22 is no. 24 is no. 26 is no. 28 is singular. 20 no. 20, 30 no. 30, the inverse of A is 2 by 2 matrix, 2, negative 5 halves, negative 3, 4. And 34 is
32.
Yeah, 32 is singular. 34 you didn't do.
You didn't do.
That's what she said, and I don't remember.
I thought it was 34.
I
just wrote it down.
34, whether you did it, if you did it, is 3 by 3 matrix, negative 4, 29, 9, 7, negative 6, negative 2, negative 12, 10, 3.
I think my brain equated 34 with 32 since we wrote another
equation as a matrix equation, then use Gauss-Jordan elimination on the augmented matrix to solve the system. Great. It's a weird instruction set, but sure, why not? They tell you to do one thing and then do something different. Great. Okay, so how do I write it as a matrix equation?
Matrix times the x's equals the answers.
8, 3. Okay. So I don't know. This is a very strange instruction set. So as they say to do that, and then use Gauss-Jordan elimination on the augmented matrix. So write it that way, and then write it the other way for some strange reason. I don't know why that is the instruction set, but you know, whatever. Negative 5x. So then you punch that in your calculator and put it in a reduced row echelon form and put it in.
Wait, we're not just allowed to put this in the calculator now?
This one, yes. That's wait. I have said that multiple times at this point. You will have to do one by hand. One.
So it would be good to
And it'll be a 2 by 2.
How do we make, great. How do we augment a,
You would just put a 3 by 4 matrix in there,
oh,
and then do it that way.
On 18, I put mine in the calculator, and I came out with weird fractions. So I don't, maybe, hang on, before we look at it, give a second.
You could have punched it in wrong.
That's what I was thinking. Oh yeah, I wrote it down wrong.
So there you go. There you go. There she goes. There she goes again.
I like everything over 17.
I think that she's a serial killer. Because she goes running through his brain. That's like deadly. That's not a nice thing to do to somebody. You shouldn't run through people's brains. Don't do that. Metaphors are dumb. Okay, what else do we have? 8. Who do we appreciate? Why do you need help on 8? Were you acting confused or did you just make a little mistake and you're mad about
I
it?
got none of the numbers right.
Okay.
And so I think I made a big mistake.
Okay. Numero 8.
I got the first one right. I just didn't get the second.
B times A is the only thing that we can do because A times B es imposible. It's undefined. Does not exist. Bigo problemo. Okay. So we're going to multiply this one. Times this one. 2, 4, 6, 8. Who do we appreciate? I don't know.
can be a 4 by 3?
I don't understand copyright law. Because how is Mickey Mouse in the public domain? I thought like if you were actually using it like in a like proper
The
like,
original Steamboat Willie Animations version of Mickey Mouse is in the public domain. However, any changes made afterwards to Mickey Mouse, such as the overalls and the
you go. Look at that. You knew a thing to help my brain. Cause, like, I understand why Winnie the Pooh is in public domain, but Mickey Mouse didn't make any sense to me. Cause I thought, cause not everything old is in the public domain. Anyway, what should we do?
Okay, is it the top row? I need to come over here so that I can explain my protocol.
You're gonna be on camera!
Okay, so is it here times da da da, here da da, okay.
I don't know what I did wrong.
I don't
We
know.
don't
So
have to, we
it's-
don't have to do it.
So it's row by column.
Row by column.
So it's just distributing.
Well, kinda.
Well, it's the same concept. You take the 1 and you multiply times da da da.
Well, 6 times 6 is 36.
Well, yeah. It's more complicated, but same concept.
Minus
That's my issue, I
32.
I added the sixes.
There you go. And then 6 times negative 9 is negative whatever that is.
54.
54, yeah, that's my brain was going slow. Because my brain was telling me it's 42, and that can't possibly be right. And then minus 24, and then, is this what you did, or did you did something else?
I don't know. I kind of tried to do it in my head.
Come out as a 4 by 3.
Yeah,
I don't know.
that's just the first two.
Probably just need to write more.
Will it be a 4 by? Yeah, it'll be a 4 by 3.
So like 4.
Because it's
like,
a 4 by 2 times a 2 by 3. So it'll be a 4 by 3 at the end.
I have to have a 3 by 4.
Well, let's keep going then. See, you understand? Like you understand what I've done,
Yeah.
right? Okay, great. So then it would be 6 times 10 is 60 minus 60 whatever it is. Why can my brain not multiply today? 64? 8 times 8 is 60.
64.
64. Yeah, and then, so that's the first one done. And then you do those, right?
Yeah. I think
Yeah.
I was trying to do it without like writing it down backward, and so I just tried to do it from the book.
Oh.
And so I think I was getting confused.
Yeah, don't do that. That's a good way to mess it all up. Yeah.
That's partially why I got confused.
Yeah. What other questions do we have?
Oh, in the like
In the beginning.
20 through 26, can
Mhm.
it be a negative 1, or does it have to be a positive 1?
Has to be a positive one.
Because on 20, I got a negative 1 for the first one.
Brian made a mistake. What did you do? How are you doing it? You're multiplying them?
Yeah.
Yeah, you probably made a mistake. We can do at least part of it real quick, for
It's
sure.
negative 24 plus 25. And that's
Is 1.
actually 1.
As you say it out loud.
Yeah.
Yay.
That's
Brain
funny.
is a funny little creature.
I think I just am trying to overcomplicate things.
28.
28.
Because I got an answer and I guess it wasn't correct.
Okay, so we supposed to find the inverse if it exists. Well, it doesn't exist. It's what the key says. So the matrix we're supposed to find the inverse of is this one. 4, 8, 1, -2. The first thing we would do is to find the determinant. So how do we find the determinant of a 2 by 2 matrix?
1 over AD minus CD.
So yeah, that's the full inverse, but just the determinant part is that bottom part of the 1 over that bottom part, right? So we multiply this and subtract this. So -4 times -2 is +8, and then -8, which gives us 0. Therefore, QED inverses and Cramers rule. What are you whatting about?
Somebody at the factory
What?
wrote on my paper.
What?
And that made me forget what you said. What was the name of the lesson?
Go to page 388 and copy those words.
It's a lot of words.
So using should be capitalized. Like the type.
That is debatable.
It's a type. But not
Correct, but
Things.
not all helping that. So it is what. So by some standards, if the word is a linking word and it's 3 letters or less, you don't have to capitalize it. By some standards, all of them are capitalized. So kind of depends.
Yeah.
And then any linking words not capitalized is the standard they went with on this book. But you can debate your method if you want. I definitely don't capitalize in titles things like and or the. Well, unless the is the first word, then I capitalize them. That is personally what I do. But if I was writing solving linear systems using inverses and Cramer's rule, I would think about, as I was making that page, should I capitalize using or not? That would be a thing that I would do. And I can tell you right now, my brain would do that. And I would spend more time than I needed trying to decide whether I should capitalize using. And what I would choose would probably depend on the day. So we are expected to solve this using inverses. Right.
Alright.
So, if we start out with this matrix equation, and we go to solve it, the solution would look like this. Right? We would take the inverse of A on both sides, which would cancel that A, and then we would have a solution matrix. So that is exactly what we're going to do with this. We're going to write this in a matrix equation. Yes, you will have to do one of these on the test by hand. Yes, it will be a 2x2 in this context. And so I should also point out, while I'm thinking and pointing randomly at things, that normally, up until this point, up until this class, what I say is you can get most of the credit for doing a problem even if you don't use the correct method. It's like it says solve by elimination, you solve with substitution, you can still get most of the points, you get minus a point or 2 if you get the answer right. This one, that is still kind of true. However, if the instructions say solve using a given method and you just write the answer, it will be all wrong. So you have to solve, if it says use a method, then you have to use some method by hand in order to get at least most of the points. Does that make sense?
Yes.
Because y'all all know how to punch into the calculator now, and that's great. I love that for you. It's wonderful. When you if you have to go do solving systems in college for some reason, you'll be glad that you know how to shove it in the calculator at this point. So that's great for you. But okay, so we need to start by finding the inverse of A. So what do we do there?
Determinant.
Find the determinant of A. So the determinant of A is 2 times 5, which is 10, minus negative 3 times negative 3 is positive 9. So the determinant is Juan. Not Juan, but Juan, right? which diagonal do we flip and which one do we flip the sign?
AD you just flip, and then BC you flip the signs.
So this would be here, and this would be here, and these would both be positive 3's.
And then you multiply it by 1. How amazing. The same number.
Yes, it is. That was nice. This would equal this one times this one. So 5 times -1 is -5, plus 9 is 4. And 3 times -1 is -3, plus 6 is 3.
Wait, how are we doing again?
Row by column, and then row by column.
Can you write out
I
the
can.
process?
5 times -1 plus 3 times 3, which is 4. And 3 times -1 plus 2 times 3, which is 3. When you first learn this method in Algebra 2, I don't love this method. However, at this point, it's not a bad method. It's a pretty good method, especially for a 2x2 matrix. Especially because finding 2x2 matrix inverse is not very hard. Okay. Let's do a bigger one.
Beaker?
Yeah, bigger.
Beaker? Oh no.
But not beaker. Only bigger. Let's solve this one using a matrix. Actually, let's do this as a word problem. Sounds great. So we're gonna do guided practice from page 389, guided practice 2. Industry. During 3 consecutive years, an auto assembly plant produced a total of 720,000 cars. If 50,000 more cars were made in the second year than the first year, and 80,000 more cars were made in the third year than the second year, how many cars were made in each year? So, we need to figure out how to write some equations from that mess. So what should we do?
Start putting together what we do now.
So, year 1 plus year 2 plus year 3 equals 720,000, right? $50,000 more cars were made in the second year than the first. Okay, so this we got to start like puzzling out what's happening here. So, well, this equation is going to have some zeros in it. That's great, I think, right? So 50,000 more in the second year than the first year. So year, which one was more? More was in the second year?
Yeah.
So year 1 plus 50,000 equals year 2. subtract off these years and turn these guys into year, let's see, let me actually line this up. Year 2 minus year 1, right? Equals 50,000. And year 2, or year 3 minus year 2, equals 80,000. Does that look accurate?
You wrote no, never mind. Thought it was 800,000 up on that for some reason.
This is 800,000, but it should have been 80. I wrote it right on the one we were
No,
reading.
it was 80,000.
Oh, yeah. That's funny because
Okay.
my brain did the same thing your brain did, and like after you had already realized your brain was being weird. Okay, great. So you might want to put these in here just to help you remember. You don't have to, but you might want to. So we're supposed to solve this using inverses, and this is a 3 by 3 matrix. Our method for finding the inverse of a 3 by 3 matrix is to shove it in your calculator. Great. So the matrix equation would be this one. And actually, honestly, this one you could probably do by hand. As I'm looking at this. This one is like super simple. Like if I made you do this one by hand, you could do it. Because this one is a bunch of ones and zeros already. Might even almost take less time. So we need to find the inverse of this. So that way we punch in our calculator, right? It's going to equal whatever it equals times.
Wait, how do you just plug it in as star REF?
No. That would be using Gauss-Jordan elimination.
No, but what are you doing to find?
Remember you just raise it to the -1.
It gets us 1/3, -2/3, -1/3.
1/3, 2/3.
-2/3.
Negative
-1/3.
1/3.
1/3. 1/3. -1/3. 1/3. 1/3. And 2/3.
Somebody else punch it in. Make sure it works right. Do you know how to put a matrix in your? You know how to do that already, right? Because you just put the matrix in and then you do exponent -1 and it'll give you the inverse. I was able to last week figure out how to do all the matrix stuff on that calculator without having to Google it. So I think you got this.
I figured out how to do it all.
You're so smart.
Okay.
Yeah, that's right.
Great. So let's find the answer, shall we? What is 1/3 times 72,000?
1 second.
Or 72,000 divided by 3.
240,000.
240,000 minus what's 2/3 times 50,000?
1 second.
How do we get 24,000?
A third of 720,000.
Wait, it's row by column, right?
Yep.
Row by column. So, I mean, 1 second.
million, that doesn't sound right. 100,000, oh yeah, it would be a fraction. Cause it's 100,000 divided by two, I mean three.
What are we doing?
We're multiplying these two matrices together.
Wait, how?
Oh my god.
Oh, oh. Okay.
And then 26, 666.66.
You multiply these together on the calculator, no?
And then minus something with 2/3. Yeah, see, that's where it starts to be a whole number. 80,000 divided by 3. What are you saying?
Can we multiply these together on the calculator?
You can, but if you do, you won't get full credit.
But we wouldn't get a problem like this.
You absolutely would get a problem like this. Why would you not?
A word problem?
You would get a 3x3 matrix that says solve using inverses.
It's like, right here, I found it, it's right here. Sorry. Okay.
Mm-hmm.
That's an awesome shirt, I
That's
love
a
it.
lot of numbers.
Okay, so, here we go. You're starting with 5 to 60, then you got 2,000, now you're ready to spend. Just don't forget your own fees. Okay?
So in year one, they sold 36,000. That's what I got. A third of 50,000 is what?
I did not get 36,000. How did you get 36,000?
This minus this minus this is what I did.
I got 180.
You did?
Me as well.
That's what the calculator got.
That's what the calculator got.
And
Well, let's see what I did wrong. What am I doing? 72. That's clear. 2, 4, 3. What am I doing? I know what I'm doing. Minus 1. No. Yeah, 100,000. Divided by 3 minus 80,000 divided by 3. 180,000. I don't know how I got 36,000. And then you do the next ones, and you get whatever you get. What do you get?
230,000.
Actually, at this point, so, and then you get 80,000 more than that, whatever that would be.
310. Wait, what did you get?
So, what you would have to show on this problem in order to get full credit is all of this except this line.
Yeah. So just so I could have just multiplied the matrices together in the calculator.
You could have,
Okay.
if you wanted to. Or you could have done this on the this part on the calculator, done it that way, or the other bit. If you showed this much on your paper, I would give you 100% of the points for this problem. Make sense? Easy peasy?
And you use the calculator to get the inverse matrices of that. Okay.
Okay,
Okay.
so let's talk about Cramer's rule. We're even dangerously close to a test, so partial fractions. Oh yeah, fun.
How dangerous?
And that's it. We're not going to do linear optimization. So yeah, we have this lesson, then one more lesson, and then, well, and then we go over the homework for that and then test. Yes, yes. Accurate. We're getting also very dangerously close to spring break. Cramer's rule, where we use determinants. So for a 2x2 matrix, x equals the determinant with x flopped out over the big determinant. Y equals the y determinant over the coefficient determinant. This all makes sense when I like to do an example. For a 3x3 matrix, all we have to do is add the z1. For a 4x4, you add some other letter and keep on going. However big it is. Cramer's rule is absolutely, without doubt, the method for solving large matrices by hand. If you're gonna solve a 3x3 or bigger by hand, Cramer's rule is the way you want to do it. Period. Like there's no close second. You don't want to use elimination. You sure as heck don't want to use substitution, and you don't want to use inverses either to do it by hand. So that's just going to be a big pain. But Cramer's rule, if you are forced by an evil being teacher to solve a large matrix by hand, this is the way to do it. Okay, so we're lucky. We're going to do 2 examples right now. Let's start with a 2x2. We're going to solve this one. 3x, so I love that they're using subs and stuff now. Wonderful thing. X sub 2 equals 6 and negative 4x sub 1 minus x sub 2 equals negative 13. And so arguably, you could also say solving 2x2 matrices by hand is great with Cramer's rule too. We can solve this with elimination or substitution if we want to, of course, but the instructions say solve it using Cramer's rule. So first we have to find the determinant of the coefficient matrix. How do we find the determinant? What do we do to do that? Yeah. So we multiply the positive one and we subtract the down diagonal, and then we subtract the multiplication of the up diagonal. So written out in its entirety, that would be 3 times negative 1 minus negative 4 times 2, which would be 5. The d sub x, what you do is you find the determinant of the same matrix, but where the x's are, these are x, instead of being x's and y, these are x sub 1s and x sub 2s. So the x sub 1s, you swap out the answers. Here's for those. So we would put a 6 here and a negative 13 here, and then these would stay the same. Negative 6 is, 6 times negative 1 is negative 6, minus negative 26, right?
Plus.
Which would turn into plus. Haven't said anything wrong yet. first column would stay the same as it was. The next column would turn into 6 and 13. Sorry, sis. 3 times 13 is 39.
What are you swapping? How do you know what to swap out?
Swap out the x's for the x one and the y's for the y one.
Okay, so on the x's you're using the stuff on the right, and then the x's, and then the okay.
On the in the y's, like the x one, we changed the x's to the answer one, and on the y's we changed the y's to the answer one.
Okay.
Negative 24, which is positive. It's 63. Did I copy something down wrong? Or the answer
It's
is just
negative
okay?
15. You did the plus twice. You made it plus, and then also made the middle sign plus instead of just doing it once. And also the 39 is negative. Actually, that's probably the issue. Because the 13 is negative. You didn't write that down.
Oh,
There we go.
there it is.
Never mind. My original logic was flawed, but it is negative.
Negative 15.
Yahoo and such.
So, x of 1 equals 20 divided by 5. So it's 4. And x of 2 is negative 15 divided by 5. So it's negative 3. Easy money. Let's do a bigger one if we're extremely lucky.
Meet the letters.
That's Cramers rule?
That's Cramer's rule.
I thought Cramers rule was the diagonal or whatever.
So that's what we did, but we did it with a 2 by 2.
Okay. Now we're gonna do the 3 by 3?
Yeah, but we're going to use the method we learned this year. So we're still not going to do the. We're going to do the little sub matrices. Cause magic. But if you want to do the. You can.
Mathematics.
I don't want to do it. I don't want to do it.
Okay, let's do these one. We better make some room, yeah? Negative x. For the sake of time, I'm going to pretend like they didn't do that. And do this. Because y'all know how to move stuff from one side of an equation to the other. Y'all have big brains and things.
That's a 4, right?
Yep. 3x minus 6y plus z equals 15 and 2x plus 5y equals negative 1. Okay. So, we gotta find a bunch of determinants. Start with the big one. Well, the big one. I don't know why I said the big one. That doesn't, they're all big. 3, negative 6, 1, 2, 5, 0. How do we find the determinant of a 3 by 3 matrix?
Give it a
Okay, you take you choose one on the top.
Yep.
And then you eliminate that column, and you just deal with the 2 on the bottom rows.
That's true.
Bottom rows.
That is true.
So you think about it with your magical little brain.
1 times the determinant of this guy.
Oh.
Wait, what? This.
Or you can do the if you want to do it that way.
I don't know how to do the.
What? That's how you learned how to do it last year. Where you
I was
rewrite
not
it.
last year.
Well, then I'm not talking to you.
Oh, the.
Or you do this and then you go. Yep. That's what you were trying to remember. You can do it that way if you prefer. I don't care.
One,
What?
two,
I guess
six,
it's
two.
great. -1 times 0 minus -5 plus 2
Wait,
times.
can you write it out real quick?
No, but you can.
I just need to remember which ones
Write
go
it.
where.
Write it. And you tell me what you did.
Is it -6 times 0
Yep.
minus 5? Okay.
Yes. See. I promise there's a reason for the push. I don't just push kids off of ledges. Although sometimes it seems like it might be fun as long as it's not a too tall ledge. 15 plus 12 is.
It's always plus minus plus.
Yes. 15 plus 12 is just 27. Yes.
Okay, hang on. On the first one, why is it -5?
On the first one, why is it -5?
Yeah, in the parentheses.
Because -6 times 0 minus 5 times 1. Because it's this minus this.
Oh, I was thinking you flipped signs and stuff.
No, I didn't flip any sides this time. So 5 minus 4 plus a whole heap. 100 and 2 times 3, 106. That sound right? Did we do it right? Are you proud of me, Mom?
108.
Because that's what comes in my brain. Negative 60 plus 2 plus 32 plus 4, 320 plus 4, 324, does that sound right?
No.
What?
Are we sure we did the third one right?
Yes.
Are we sure?
Am I sure?
15 times 5 is 75 minus,
minus 6.
oh, minus 6.
No, plus right.
No, minus 6.
Why is it minus?
Because negative 1 times negative 6 is positive 6, so
Six.
minus positive 6 is minus 6.
It still got me 81. 15 times 5 is 75 minus. Oh, I did plus. Okay, never mind.
Yeah.
I am a city.
So it'd be 69, right?
Yes.
4 times 69 is 24 plus 30. 240 plus 36 is, yep, 376. 376.
276.
24, yeah. Yes, that's right.
218. Woohoo.
Yeah.
I have to keep going.
Okay, so we're out of time, but the way you would finish this problem, I've got to write your homework because y'all need homework to do. You'd be so sad if you didn't have homework, right?
Spare us.
You would do this for the y one, and you would do this for the z one, and then you divide each one of those by 109, and you get your answers.
I remember this.
Magical unicorns, great.
This
Your
is
What
homework.
magical unicorns are.
So, for clarity's sake, this homework set you would do by hand.
Can you use the calculator?
You can use the calculator to like check yourself and do the multiplication and all the
Sanity
things.
check.
So basically, exactly what we've been doing.
Yes.
Yeah.
Right. We've been doing it in class right now.
Yes. Yes.
Oh, must we have the homework?
Yes. Page 392. Numbers 2 through 18 evens. Don't let the low numbers fool you.
What numbers? That's 9 whole problems.
Yeah, I know.
They look like this.
Okay, goodbye and
No
such.
paper again.
I have stuff to do with my Wednesday.
Okay,